Welcome to BKW Physics. My name is Mr. McConnelly, and today we're going to go over a problem that seems very confusing on the surface. And I'm going to have Cheyenne read that aloud.
The helicopter in problems 69 and 73 now descends at 5.0 meters per second.
Okay, so we know that the helicopter has a velocity of 5 meters per second, and it said descending, so from that I picked up on the idea that it's a negative because it's a vector, it has direction, okay?
As the bag is released. After 2 seconds,
2 seconds.
What is the bag's velocity?
What's the bag's velocity? So, since they're asking about what the bag's velocity is after 2 seconds, I can back up to my original -5 and realize that that's an initial velocity. Because the bag is falling, and then later they want to know what speed it's falling at a later point, so that has to be the final speed where that is the initial speed. But there's one other piece of information that you're automatically given when you're dropping something, which is what?
Acceleration of gravity.
Okay. The acceleration of gravity, which is -9.81 meters per second squared. So this is our players, our givens. And so the first one says, okay, what's the final velocity? And if I look at these 4 things, the equation that should come to mind is Vf equals Vi plus At. The A being a G in this case because it's gravity. But, see what I'm saying? And it's already rearranged in the right way, so I'm going to put the -5 meters per second right in there. I'm going to say plus a -9.81 meters per second squared, and I'm going to times it by a time of 2 seconds. I put all that into my handy-dandy calculator, and I get a -24.62 meters per second, and then because of sigs, I'm going to make it -25 meters per second. So I know, after 2 seconds, that this bag is going -25 meters per second. That's great. What does it ask next, Cheyenne?
How far has the bag fallen?
How far? So now we've kind of checked this one off our list. I can actually fill it in as something I know. But now we want to know how far. What's our distance? Now there's probably a variety of ways you can do this, but I think the best way to do this is to go to the equation d equals VIT plus 1/2 GT squared. This equation seems to work really good when you're trying to see how far something has fallen, and you have the time, and that's just about it. So basically, if you know the time and you're dropping something, this equation really tends to work for you. So here we go. This time, we know that the initial velocity was a -5 meters per second, which is different than some of the problems we did yesterday and last night, because we were always saying the initial velocity was 0, but in this case, you're actually dropping it from a helicopter, so you actually have an initial velocity. The time is 2 seconds. You have gravity. And always remember that your 2 seconds on the end, you gotta square it. Alright? I see some people laughing because they forgot to square it. Probably. So, anyway, plug this in the calculator. This ends up giving you a -30 meters. Okay? So we've answered the question. That bag has fallen -30 meters. This is the bag. In 2 seconds, it fell -30 meters. Okay, fine. What's the next part say?
How far below the helicopter is the bag?
Okay, so we almost need a little visual here. So I'm going to draw us a really lame helicopter because I don't know how to draw a good helicopter. And helicopters, I think, look something like this, okay? So you draw a helicopter, and this helicopter, you know that you have dropped a bag out the window. Here's the bag falling. And the bag has fallen -30 meters. But all the while, the helicopter continues to go down itself. So in essence, it's chasing the bag downward. So what we really need to figure out, because we know how far the bag fell, we got to figure out how far did the helicopter go down. Now let me ask you the important question. Is the helicopter accelerating? Some people are saying yes, and some people are saying no. There's disagreement here. The answer is the helicopter is not accelerating. It actually says in the problem back in the beginning that the helicopter and the bag, this is the helo and the bag, are both going down at a constant speed. So there is no acceleration. And if the helicopter itself has no acceleration, then we can jump right into equation velocity is distance divided by time, because that equation will work when there's no acceleration. Yeah, Joe?
I didn't actually take into account when I did the problem, but thinking about it now, wouldn't it technically be accelerating because it's changing direction?
It's not, because you continue to go down the whole time.
I see
Your
it's
direction
starting,
is-
It's not starting and then going down, it's going down.
Yeah, as the problem starts, the helicopter's already falling. So that's a great point, but you're thinking of it a little bit incorrectly. Now, if the helicopter was going down and then started going sideways, I'd agree with you. But the helicopter continues the same direction, we're fine. All right, so let's figure out using this equation and rearranging it, just to do velocity times time. Let's see how far the helicopter actually went down. Now, the helicopter was going at -5, and it also went down for 2 seconds. So I can do that in my head. We got that it went down -10 meters. So this is the helicopter going down 10 meters. This is the bag going down 30 meters. So it's the helicopter is chasing the bag. What's the actual separation? If this one is going down, if the bag is going down 30 and the helicopter is going down 10, can you see that they're only separated by 20, Joe? All right. So 20 meters is the separation. And 20 meters of separation is the answer. So that wraps up a nice physics problem for today. Physics.